Kim, mic is hot.
Hello, everyone. Welcome from United Astronomy Clubs of New Jersey. It's astronomy time again, and we are currently live with Lonny Buinis and his lovely wife, Jan, presenting What's Up in the December Sky. Jan will be doing Lonny's intro tonight, and with that, here we go, Jan.
Hello, Kim. Thank you for that wonderful introduction. Billions of years from now, when the Milky Way and Andromeda galaxies collide, what Lonny would like people to remember him for is not only showing good viewers like you what's up in the sky for the 26 years since UACNJ got started, but also having been the kind of person who has only appropriately annoying to his wife, Jan. I beg to differ on that. Lonny respects practical experience over book knowledge, but figures some of you might want to know why we should believe anything he says. He holds degrees from Stevens Institute of Technology in physics and computer science, and is a member of the International Association of Astronomical Artists. The Lonny Buinis Observatory was dedicated at UACNJ in April 2016. Still, Lonny is perfectly comfortable if you choose to find telescope owners who will share, ask questions, and see what's up in the sky for yourselves. Without further ado, Lonny Buinis.
Thank you, Jan. Thanks, Jan. Ladies and gentlemen, children of all ages, welcome to What's Up in the December Sky, part of a continuing series for 26 years. We'll be doing What's Up in the January Sky, and What's Up in the February Sky, and March, and then back again in April. We'll be returning live to the observatory location in Hope, New Jersey, where we have one of the darkest sites in the state of New Jersey. So I hope you can join us live, and you'll see me there the first Saturday of each month talking about what's up in the sky. So for now, we're looking at a nice shot of several things that we're going to be looking for in the December sky at night at a convenient time, like 8 o'clock at night, 9 o'clock at night. And so we begin with a wonderful grouping of planets that happened in Jerusalem, 7 BC. There were 3 instances of the planets Jupiter and Saturn coming together very closely within 1 degree of angle, or as astronomers like to say, 1 degree of arc. That's about, well, 1 degree, that's about twice the size of the full moon is seen by the naked eye from Earth. So in other words, as we say in scientific jargon, close, right? Jupiter and Saturn were close the way they are tonight, the way they've been for several weeks now, coming together. This wonderful event that we're witnessing now was recreated 3 times in 7 and 6 BC. And the astronomer David Hughes, in his book, The Star of Bethlehem, An Astronomer's Confirmation, written in 1979, claims that he's got very good evidence to show that the Star of Bethlehem was actually a triple conjunction, a coming together 3 times of the planets Jupiter and Saturn in the year 7 BC, ending 6 BC. Now, we can see this now. It's a rare grouping. Before I talk about my next topic, the rare grouping that you see tonight did happen again in the past. It will happen again in the future. Last time was in the year 1623, where it was so close to the sun that everybody missed it. You probably heard about that. They were complaining about it on Twitter. Before that, in 1226 AD, it was great. It was easily viewable. And if you want to wait, if you miss it this time, don't worry. It's going to happen again March 15th in the year 2080. I won't be around. Some of you younger people might, but if you don't want to miss it, go out tonight, go out any clear night, and catch the 2 planets within arc recently, December 1st, I believe it was, 7 minutes. That's just a little bit more than the human eye can resolve. When you look at the moon, you can see down to about a minute of arc. You can see that little round circle at the 2 o'clock position. That's Mare Crisium, the Sea of Crises, a big sea twice the length of New Jersey. So before we get to taking a live look at what's up in the sky, not the real sky, simulated sky, about some news. Did you hear about the space junk? Yep, 2020 SO. 2020 SO is actually made by human beings. It's a new mini moon, and it was caught by the Virtual Telescope project. It is, in fact, a leftover from the early space age exploration. It is Surveyor 2, a space probe that actually landed on the moon, but its stage, its upper stage that flew it to the moon that you see on the right here, missed the moon. It was supposed to crash land. There was a mistake in the navigation, and the thing flew past the moon into its own orbit around the sun. Well, this was 1966, and guess what? It's come back. You can actually see this if you go to the Virtual Telescope Project's website. You can see them zooming in on this leftover relic, a new mini moon, about the size of a bus. And it's following us temporarily like the moon follows us. But it has its own independent orbit around the sun in a way, influenced by the Earth, just as the moon can be considered to be its own planetoid going around the sun. The Earth and Moon actually revolve around a common center, which is within the Earth. Now, if you look at a planet like Pluto and its big moon Charon, they revolve around a common center that's outside of Pluto. That's it for news. If you'd like to see what's up in the sky, go to seesky.org. For you people interested in the sea as well as the sky, you can see both at this website. And there you'll find a calendar of events that I like to use for each of my talks to tell you about what's coming. If you haven't memorized this link yet, or if you haven't taken a picture of it or scribbled it down on your iPad, not to fear, just remember seesky.org and click Explore the Sky, and then click the second tile, Astronomy Reference Guide, which will inundate you and confuse you with tons of information about the sky. Very cool, very handy. But I'm going to look at the astronomical calendar, which shows me the whole year. Whoops. The whole year, but you can go backwards in time or forwards. So if I click on 2020, I'll see the entire year from January through December. And I just focus in on certain events this month, the ones that are easy to remember, like a meteor shower. The big one, prettiest of the whole year, is the Geminids. These are the brightest seen from New Jersey. And that's basically because we live in a light polluted state, lots of street lights, right? Lights from industries, sending light up instead of down. You'll notice that many new highway lights are configured to send more light down than up, which interferes with astronomical viewing. And that's a good thing, wastes less energy. But if you check out December 13th to 14th, overnight, stay up late if you can, you'll see debris left over by an old asteroid, 3200 Phaethon. Real easy to remember, right? It's not like Halley's Comet. Well, it's an asteroid. It's a pretty much a big piece of rock. And of course, a lot of asteroids are just loose collections of rubble held together barely by gravity, very weak gravity. You go visit an asteroid, you can probably jump the asteroid just under your muscle power, your leg power. Now, this shower, being the best of the year, the brightest, does run more than just one night, but it peaks. It's weak, stronger, weaker. And that's because we're going through the debris field of this asteroid. The Earth catches up with this orbiting debris, and all of the debris comes out at an angle over the whole sky, but it seems to converge from a point. Just like railroad tracks converge in the distance, or the painted marks on a highway, they're parallel, right? They never touch, but they seem to come together in the distance. And so the same thing happens to the meteors. They are on parallel tracks. As they enter our atmosphere, they start out as meteoroids. In the atmosphere, they're meteors. And if they land, they are, audience, don't all speak at once, meteorites, right? So go out and use highly specialized scientific equipment, this, your naked eye, and a nice comfortable chair, preferably one that can lean back a bit. And that's all you need. Look over the whole sky over a great angle. You might see up to 50, 60 meteors per hour or more, but, and this is an important warning, that's only in really dark skies. If you live as I do in a suburban area, you might be lucky to see one bright one, well, maybe a couple, several per hour. But try to do it. The later you stay up, the better. We are looking right down the Earth's shadow, out right south up in the sky around midnight. So if you can stay up late, that's good. If you can't, try earlier. And see if you can find the winter constellation Gemini, which is late. And that's where they seem to come from. We've got a couple of lunar events. Lunar from the Latin luna, right? Luna like Luna bar, my favorite lemon bar, which I hope to have one after we finish this talk tonight. The new moon on December 14th in the middle of the month. Why is the new moon a good thing for astronomy? It's near the sun in the sky, right? 400 times closer to us than the sun at 250,000 miles. The sun, 93 million, right? So you want to make a rough estimate, 250,000 compared to 100 million, 400 times. Well, the lighting from the sun is such that the moon is not lit at all. So it should not shed any light. Great time to see faint objects in the sky. We amateur astronomers, I am not a professional astronomer. I'm an amateur, like the people who are good enough to bring you this presentation tonight from UACNJ, a volunteer organization of many astronomical societies and organizations in New Jersey and elsewhere, our neighbors west and north, maybe some south. We're doing this all because we love to, not because we're paid. We're amateurs, right? Now, amateur astronomers like to look for faint objects called deep sky objects. Deep in the sky, far from us, thousands of light years, stars hundreds of light years away, nebulas thousands of light years, right? Best time to see them, new moon. There's also a total eclipse of the sun by the moon. This, you would expect this to happen every time the moon orbits the Earth once a month. It should cross the sun, correct? It would. It would if the moon's orbit was lined up with the Earth's equator exactly, but it's not. It's tipped about 5 degrees, and so we have to wait for the whole orbit like a top and bring an intersection point so that the moon does cover the sun. Not that common, maybe a couple times a year. We're not going to see it. It's visible in the southern part of the world, especially Chile, but you can get a lot of good eclipse information from Fred Espenek's website that's been up forever. Look up eclipses, total eclipses, solar eclipses, lunar eclipses. And you get really cool maps like this with all the times of the eclipse. So any of you going out there boating down to Chile, good luck with the eclipse. I'll let you know when the next one comes up. We have another big bit of news, or a bit big of news, take your pick. When the sun reaches the lowest point in the sky, if you were to draw the Earth's equator out into the sky and draw the path of the sun in the sky, the two would intersect at an angle. That's because the Earth doesn't orbit the sun straight up and down, perpendicular, 90 degrees to the orbit. It's tipped 23.44 degrees, roughly 23.5 degrees. And that gives us our seasons. And that means we have the beginning of winter. This is called the winter solstice, December 21st. First day of winter in the northern hemisphere, first day of summer in the south. We can use programs like Stellarium, a free program, a computer program that I will mention again at the end of my talk, to simulate the sky on a computer or a phone or a tablet or a phablet or a laptop. Anybody know what a phablet is? I'll give you a few seconds to think about that, a phablet. I wrote a science fiction story set in the near future in which they use phlablets. So I'll let you guys figure that out. I'll tell you what I think it is at the end of my talk tonight, a phlablet. Use your phlablet on Stellarium. I'm sorry, they haven't made them yet. We'll simulate the sky in just a few minutes with Stellarium and see what a meteor shower looks like. There's a second one, a weaker one, around the same time as the winter solstice. This one has only a few meteors per hour, bright ones. And of course, failed to mention that a meteor is just a little, generally a little dust grain up to the size of a grain of sand, burning up in the atmosphere as it comes in at 5 miles a second. Now, that's pretty fast. You mathematicians, arithmeticians in the audience, multiply 5 miles per second times 3,600 seconds in an hour, and you get pretty darn fast, right? Miles per hour. In other words, these little things are coming in through the entire troposphere, 5 miles deep. If they were to come in straight, they would do it in 1 second. 0, 1,000, 1, 1,000, 0, 1, 1,000, just like that. Amazing. Of course, they're coming at an angle, sometimes through tens or hundreds of miles of atmosphere. They burn up from friction. Bigger meteors, really big ones like asteroids or smaller meteorites the size of fists, do not heat up entirely. They just ablate. They just heat up on the outside. Big news. This time we're going to take a look in the simulated sky in a few moments at Jupiter and Saturn putting on a conjunction. 7 arc minutes at the closest approach. So they'll look like a bright double planet in the west after sunset. Happened in 7 BC. Astronomy used the Star of Bethlehem, and he can actually use that conjunction to date the exact birth of Christ at September 15th, when there were shepherds in the fields in that part of the world, because that time of the year, it was still warm enough. Before we take a look at the planet Mars in the sky, I'd like to show you what the sky would look like if we simulated it on a computer. And sharing my screen is let me know, anyone, if you don't see what I'm seeing as I described. I'm facing north. How do I know I'm facing north? Because my good friends, you go outside and look for the giant letter M, right? Don't believe everything that Lonny says tonight. When you look in the real sky, the star patterns that the International Astronomical Union standardized in 1930, wasn't that long ago. Some people here were still alive then. They decided on 88 official star pictures or constellations. And one of them is the Great Bear Ursa Major. Very low sky this time of year. With trees and houses in the way, you'd be lucky to see the Big Dipper, which is part of that constellation. So you see the bear, the head, the claws, the tail. What's wrong with this picture? Yeah, the bears have long tails. There's a famous Iroquois legend about the brave hunter who grabbed the bear by the short tail and hurled it into the sky, lengthening the tail. If you look above the big, following the 2 pointers.
Hold on. Hey, Lonny. Currently,
Yes.
we are experiencing a little bit of a technical difficulty here. Your presentation screen is currently gray.
Let me reshare. I'm going to quit this. Let's see. I'm going to quit this and try again. So I'm back to a video of myself. I don't know if we can see that. And I'm going to try sharing again. Bear with us, everybody. The difficulties we have now are not uncommon. Now, I'm attempting to share my Solarian screen. I do not know. I'm going to pause for a little bit so everybody can see what I see, which is stars.
All right, Lonnie, we do have video again. Sorry to our audience. There are high winds and whatnot in the New Jersey area, and it occasionally messes with our with the internet and whatnot. So thank you for bearing with us. What?
Sure. Thanks, everyone.
Hold on. It
We'll
looks
do our
like
best.
the video cut out again. Are you currently sharing?
I'm not. I had paused to let the stream catch up. So let's try sharing once again. And for those of you familiar with Zoom and Microsoft Teams, this happens quite often. I'm not using a very fast connection, but let me try to locate my phone here. All right. How's that? Can you see my star field? I'm waiting confirmation. Just let me know, Kim or Jeff or Chris.
We are working on a hopeful solution. I'm sorry, bear with us for just one moment.
It's okay.
All right, it looks like we can continue. Sorry about that.
That's all right. Thank you to Kim and the team. I know they're working very hard behind the scenes. You don't see everything that they have to go through. They have to still work smoothly. So we appreciate that. And they do a lot more than just the presentation. So when you visit us through October, I hope you'll stop by and thank them or let them show you the sky. So I had left off using one star pad to find another. We call this star hopping. So we can actually use the Big Dipper's pointer stars, which we can identify in computer programs like Stellarium by clicking on objects. This is Merak, Beta, Ursa Major, the brightest star Alpha for the first letter in the Greek alphabet. Dubhe, Merak, and Dubhe together point very close to where the Earth's North Pole is, right about here, pointing. Now we don't see the North Pole, but we do see the North Pole star, aptly named Polaris. And that's, since the Earth is spin like a top, it has a pole and an axis with poles that point north and south. People in the Southern Hemisphere are not as lucky as us in New Jersey. They do not have a south star. They have a cross that points to where the south pole is approximately located. We can easily see where the North Star is, however, and a small dipper-like object, which is appropriately named the Little Dipper, or some small bit. Between the two, the Dragon Draco. It's star Gamma. It's star Thuban, Alpha Draconis. That was our pole star in the time of the Egyptian pyramids when they were built. So you can see how far the Earth's North Pole has wobbled away a spinning top. The Earth's North Pole does wobble, but okay, it's very slow. It's almost 25,000 years for one wobble to make a complete circle. So you see how far we've come in the last few thousand years. Two more constellations make the set of circumpolar constellations that go around the North Star, never rising, never setting, just circling all day long. You see this group is M-shaped group of stars, which is the Queen Cassiopeia. Do you see her in the daytime? She's up. Why wouldn't you see that in the daytime? You won't see the pictures. Would you see the lines? No, I can turn those off as well. Would you see the stars in the daytime? No. I saw Cassiopeia being circumpolar, moving around the pole all day and night, visible only at night. If you can locate Cassiopeia and look slightly right, you might see two fuzzy blobs. I like to call them the fuzzy blobs. Stellarium is identifying them as the double cluster. It's a two open star clusters. Dozens of stars born moving together through space. Two of them, very cool. These can be spotted with the naked eye from any jump. A nice clear night. You have to have pretty good eyesight, not like mine. I have old eyes. Right, so younger members of the audience, you take advantage of binoculars with their 7x50 types of binoculars with their big exit pupils, which I won't explain. That's for another time when we meet in person. Look below Cassiopeia. At the time of year, you'll see the house. I like to call it the house. It's her husband, Cepheus the king. Looks just like a king, right? Try now. There are deep sky objects located amongst the stars, like the elephant's trunk nebula, a faint one. Right, so you can zoom in to see what some of these things look like in stellarium. They're called deep sky objects. And this nebula, a word for cloud, is a gas cloud, and someday it may become a star. As it collapses under the force of gravity to form the dust and the gas in it, to form stars and maybe even planets. That's how planets are born. We can tell because we can watch the process happening. Now, once you've learned some constellations in the north, you're ready for a real test in the south, where all the really cool stuff happens. As we amateurs like say, not just astronomers, the cool stuff happening south. When you're facing south, you're looking along the path of the sun and the Earth's equator drawn out the space. Now, we can see a little bit. We can actually show the markings. Whoops, right here. I can turn on the equator, and I can turn on the ecliptic path of the sun. The path of the sun is the red line, the equator is blue. The equator is very easy to find in winter. We're coming up on the beginning of winter. You can find it by looking for the famous constellation Orion. We're looking at Orion about 8:30 at night. This time of year, it's coming up in the southeast. It will be higher later on in the winter. The Delta 3 stars, the bright red star Betelgeuse, and Rigel, the blue star, some of the brightest stars of the winter. Beautiful alignment. The Earth's equator passes right through there if we draw into space. But look at the path of the sun. Very low. The sun is low in the winter. It will cross the equator when spring solstice, spring equinox, when days and nights are equal. The sun is right over the Earth's equator, days and nights the same length all over the Earth. And you can see that the moon and the planets follow the constellations that are along this line. They are famous. Virgo, Aquarius, Pisces, the fishes, Aries, the ram, Taurus, the bull, Gemini, you all know what that is. The ecliptic goes through the signs of the zodiac. Important to early astrologers and astronomers. and still important because they help us find planets like Mars. Also, Jupiter and Saturn have set. Oh no. Well, I'm not trying, we can go backwards in time. When it's a little bit earlier, for those of you who can stay up to it, the sky around 6:21. Let me keep going. Before it gets too late, you go out and look for this beautiful grouping in the sky. Maybe something like this, the naked eye. And they are said to be in one of the signs of the zodiac. That means they're in front, right? Jupiter and Saturn are so close that light is taking only about a half hour and an hour to reach us from them. But the light of the stars from the sea goat, Capricornus, my sign, hundreds of years or thousands. I don't know, to me it looks like a delta shape. But the sun was supposed to be there when I was born. Because the Earth precesses, as I mentioned before, and changes our pole star, it also changes which signs of the zodiac are where the sun passes. And so nowadays we have an extra constellation of Fucus, the serpent carrier, that the sun passes through. 13 signs, not 12. Astrology is off by one whole sign. When I was born, the sun was here in Sagittarius, the Archer, not in Leo. That's okay. Maybe I'll tell people my sign is not a goat. The planet Mars looking brilliant in the southern sky. We can center it in solarium by hitting the space bar. We can zoom in with a scroll wheel or with your fingers on the phone. To see that, you need a big magnification power of a telescope to see any details on Mars. Mars looks rather dull orange with some dark markings in a small telescope. You cannot see this in a pair of binoculars. You do need some magnification. But in a larger telescope, you might find it's two small moons, the size of mountains, tiny, but bright. And you might see some dark markings on Mars, like this. Mars also has frequent dust storms that obscure a lot of these features, so the features change. Long ago, astronomers thought these were seas, dark spots. We now know they're just rock outcroppings that are not covered by the general dusty sand that covers the planet. Baked by ultraviolet radiation, the surface is not a friendly place for life, but just a little bit down, underneath the soil, underneath the sand, frozen water, ice, plenty of it, plenty for future astronauts to dig up, to break up into oxygen to breathe and hydrogen for fuel. Water has both. And that's Mars. Take a look at it through a telescope or something. You'll find it bright. It's moving away. Actually, the Earth is moving away from Mars. We caught up a little bit about a month ago when it was in opposition with Earth, lined up in a straight line with the sun, and Earth, then Mars. But because we're closer to the sun, we move faster under the influence of gravity. Therefore, we're pulling ahead of Mars. Mars seems to be getting fainter and smaller. Still brilliant in the night sky. Still a good target for telescopes. And compare its reddish color with the bright red star Aldebaran in Taurus the Bull this time of year. If I let the sky, if I let the sky proceed faster up through about 9:30, right? I don't want to go too late for the young people in the audience. These constellations will be a bit higher in the sky. You're not going to see the red and blue lines, so let's turn those off. You can adjust the time. You can go back in time to see the star at time if the planetary conjunction was the star. You can look high in the sky above Mars for a huge square, huge, gigantic square. In star charts, it's small, but in the real sky, this constellation, which is apart, is so big it's the head and the feet upside down, and the body, and the princess Andromeda riding him. You would have to turn your head to see Pegasus, the flying horse. It's that big. So we undergo distortions when we map stars to flat objects like flat paper, star charts, planispheres, even computer screens, or phone screens, or tablets, or tablets, or even phlebots, whatever that is. So poor Pegasus got chopped in half to make the Princess Andromeda. Perseus is up there in the sky, came to rescue the princess, riding flying horse, carrying the head of Medusa, Medusa with the head of snakes. All these characters from Clash of the Titans, the movie, or the story of Perseus and Andromeda are up in the sky. If you'd like to see a really fascinating deep sky object, in the Guinness Book of World Record for the farthest thing in the universe that the naked eye can possibly see, that is the Andromeda Galaxy, find the great square of Pegasus. Start with Beta near the head and go to home, take first base, second base. Oh, I'm sorry, home for second, third, home for second, third, first base. Bright star Alpheratz. From Alpheratz, go up to stars and over to stars. You'll come to a fuzzy blob. Looks like a piece of the Milky Way broken off. In a pair of binoculars, it's easy. At Jenny Jumps observatories in Hope, you will see this on a clear night with your naked eye. You're looking back in time. That light to light that's hitting your eye from 2.5 million years ago. It's 2,500,000. 2.5 million years. The galaxies live for billions, so that's nothing in the life of a galaxy. In a larger telescope, such as you might see at one of our observatories, you'll see that Andromeda has two little satellite galaxies. Just as we do, the Magellanic Clouds, for those of us lucky enough to visit the southern hemisphere. This is a galaxy somewhat bigger than ours. We have 1 trillion stars in our galaxy. Latest estimate, Andromeda is even larger. And as my wife Jan mentioned at the start of our talk, in a short time, in the history of the universe, well, a moderate amount of time, we will merge or collide with the Andromeda Galaxy. The two galaxies are headed for each other on the pull of gravity. It's inevitable. They will merge, and since galaxies are largely empty space, yes, the distance between stars isn't enormous. They'll basically miss each other. The galaxies will eventually pull apart again, come close, pull apart, come close, in celestial dance lasting 3 billion, oh, I'm sorry, about 1 billion years. And when will this happen? Don't panic, about 3 billion years from now. So do not panic. It's going to be a beautiful sight to see by our ancestors. We can appreciate the beauty of colliding galaxies. We can see others doing it. You can see computer simulations that were impossible to make until just a few years ago. And the power in these computers that you own would be considered supercomputers just a few years ago. Andromeda Galaxy visible at Jenny Jump, just as is the entire Milky Way, rising from one horizon to the next. This time of year in the northwest. I'm going to wrap things up by taking a preview of the winter sky coming up towards the east. We have the famous Hunter Orion with his shield against the bull Taurus. You see the face? The bright red eye star. So Orion does not have strong colors, but your eye can see star colors very clearly. Those are star temperatures. Red cooler than the sun, yellow, star like the sun, blue hotter than the sun. Some people plan to see another dip in the sky. See it? To the side or right, facing south of Taurus the bull. Small dipper-like group of stars. If you, most of us will see about 6. Some will see 7 or 8 or more. These are called the Seven Sisters. Seven Sisters. It's a nearby star cluster, very young. Some of the gas that created it, that they were born from, gaps to make them is still visible, lit up by the light of these very young blue stars. They will not live very long. See them before they disappear, just a few 100 million years. And they're a few hundred light years away from us. An older star cluster, the Hyades, is right nearby. It forms the V-shaped face of the ball. Uh-oh. Technical problems?
It's him.
How are we doing, everyone?
Sorry about that. We were doing a background trying to get the connection slightly clearer, but you're still good to go. Sorry.
No, that's fine, Kim. Thank you for all your help. So there's a lot of cool things to see in the sky. I'm going to be talking about what's up in the winter sky or the January sky in much more detail next month. So don't miss what's up in the January sky. Let me do this again. Look up high before we go. Very high in the sky. And you will find if you face it south and bend your head backwards, you'll be looking towards the north. You'll see Cassiopeia looking like a letter W instead of a letter M, because we're looking at it from the opposite perspective. Right nearby, the double cluster that I mentioned earlier, and to the left of that, Perseus the hero, with his bright stars Alpha, Merfak. These are Arabic names. The Arab astronomers kept astronomy alive during the Dark Ages and named all of the bright stars names we use this very day. Now, from the bright star Algol, second brightest star, famous eclipsing binary. All of you in the audience with small telescopes or even binoculars can watch the star over a period of several days getting brighter and dimmer as one star in a binary pair eclipses another. Very cool. One of the first eclipsing binaries to be observed. We've seen quite a few objects, quite a lot to remember. I think I'd like to do a recap of the sky. Make sure you all get prepared for the test that we'll be delivering. Wink, wink, nudge, nudge. And so with that, I'm going to temporarily quit from Stellarium and go back to what's up in the sky. We last left, whoops, and it's refusing to work. Having problems. Oh, it even tells you. I'm trying to get back to the planet Mars that we left off with before. And here we have astronomer Christopher Go from the Philippines, who is showing us that Mars is not, it has a lot of changes. It's not static. It has dust storms. And so he caught this recently, November 21st. And what I've done was I went into Stellarium and caught a picture of the way Mars would have looked without the dust at the same time that Christopher Go took his picture on the left. And you see how the pipe stem, in the lower left part of the picture, this is called the pipe stem by we amateur astronomers. The actual name is Sabaeus Sinus and Sinus meridiani on the meridian. Sabaeus, the pipe stem, meridiani on meridian, barely recognizable because of dust. And this part of Mars on the right, almost unrecognizable. You can see the polar cap and carbon dioxide. It's that cold. The carbon dioxide in the atmosphere freezes out. So I mentioned a recap. Mary Ellen Croteau has a wonderful website. Check it out. Demilked, as a take over the milk. She makes artwork out of bottle caps. And so to recap, do not miss a wonderful, wonderful grouping of planets of the system, conjunction, and it's the bright planets Jupiter and Saturn, the outer planets after Mars. This this won't happen again until 2080. That's 2080. So don't miss it. And it is a wonderful recreation of what may very well have been the Star of Bethlehem in 7 BC, when the Magi, which meant astrologers, the Magi, which predicted this appearance and came to find it after a journey of many months, watching the planets come together once to send them on their journey, months later coming together again to herald the birth of a great leader, and then pulling apart and coming together once again on their journey home in the next year, 6 BC, counting down to 1, 7, 6, 5. Check out Jupiter and Saturn. Pulling back a little bit to see the whole southern sky, there is the moon getting in the way at 6 o'clock tonight. I'm sorry, not tonight, November 30th recently. I captured an image of the sky November 30th because I gave a talk about the sky back then. The moon was interfering. One thing to note, when the moon is out like this, it's very difficult to see deep sky objects. So you can see bright stars and planets, but a good time to see these objects we're talking about, new moon, and you all know when new moon is, correct? Right. You're all scribbling it down with pencil, paper, pen, phablets, tablets, phone cameras, right? Sure. That's what I'm going to believe. I don't know about you. Don't miss Jupiter, Saturn, Mars, Moon. They all line up along the ecliptic, the signs of the zodiac, Capricorn, right? Aquarius, water carrier. Pisces, the fishes. Aries, sorry. Aries looks just like a ram, right? Don't take my word for it. Look it up. Taurus, the bull. Great square of Pegasus. Perseus, the hero. Lots to learn about, lots to see. I'll be reiterating some of this when we come back for what's up in the January sky. Now note the difference between just in 1 month, right? So the end of November, early December. If I look at the same time of night, exactly, 6 p.m., watch what happens looking at the same direction. The sky jumps to the right. Why? The Earth is revolving around the sun. When you look out at the same time each night, you're getting a slightly different view of the sky. That's because the Earth points you in different directions. 4 different seasons, complete different directions, 90 degrees apart. Spring, summer, autumn, winter. Right? So do come back when we have more stars coming up in the winter next month. We're going to be taking a close look at the Andromeda Galaxy in Pegasus, the flying horse. There it is. Farthest thing you can see with the naked eye. We all have naked eyes. Many of us are blessed to have naked eyes. Many of us can see just with our eyes wonderful things to see in the sky. The amateur astronomers at UACNJ, when we're open, show you what everything looks like through a variety of telescopes. We've even started projecting images on the walls of the observatories, so it's easier for groups, right? So do ask a lot of questions. The only thing that you shouldn't do is kick their tripods, because amateur astronomers spend a lot of time aligning everything carefully to the sky. And if you kick their tripods, you'll make them cry. And we don't want to see that, because then the tears get in the optics, mold starts to grow. You don't want to know. It's a whole domino effect of things that just happen that we'd rather not. So I'm going to end with some light reading for you wonderful people in the audience. Thanks for putting up with our long presentation. Don't forget our website, uacnj.org. I pronounce it UACNJ, United Astronomy Clubs of our wonderful state of New Jersey, with many, it's an umbrella for many organizations. Lots of events on that site. There are still paper magazines, yes, believe it or not, paper. What is paper? Younger members of the audience, look it up on Wikipedia. It's used to print sky and telescope and astronomy magazines for decades. They also have websites. And recently I found about 10 apps you can put on your phone, like Skyview Lite, the one that I used, that you can just hold your phone up to the sky and it'll show you what you're pointing at. It'll use the GPS system in your phone. It's wonderful. If you like to do it on computer, try Stellarium and Celestia. Celestia lets you actually fly out into space, not just limit you to the Earth. And we'll take a look at that in a moment. And finally, as mentioned earlier by my wonderful wife, Jan, I belong to the International Association of Astronomical Artists. I'm a space artist and space animator. You can find my website at IAAA.org, the International Association of Astronomical Artists, links to my site, Astronomy in Motion. And here's a shameless interactive book that you can work with your fingers. Space History Mysteries Solved, including the mystery of what was the planet Vulcan and why were there canals on Mars. Right? It's available everywhere. It's cheap. It's fun. It's interactive. And now I mentioned Celestia. I'm going to take a look using that while you prepare your questions, even if they're mental questions. We always show this information when you're visiting UACNJ, but because I do want to point out that there are other things to see there than just the sky. There's a museum, there's astronomical equipment, there's multiple observatories where you get to look through telescopes or see images projected. There's a sales desk, there's star charts and maps and books and ice cream. Yep, freeze-dried ice cream. It's great. Every Saturday evening, April through October. And of course, it's not now, it's just too cold. So for now, we're going to do our talks virtually. And I hope you're going to come back for more than just what's up in the sky with me, Lonny Buinis. I hope that you're going to come and visit all of our talks. It's a lot of fun. That's what we're here for. That's what we amateur astronomers love to do, is share with you, members of the public, because we are too. And with that, I just want to show you, I'm going to stop sharing there. I'm going to show you that you can get a free program called Celestia, for which I'm going to share my screen again, which lets you fly into space and see things like an eclipse of the sun by the Earth from the moon. Imagine that. It's real time. It's amazing. You can even see the night side of Earth with the sea lights. That make it difficult in New Jersey to see anything. That's why we urge you to come to Jenny Jump once in a while. I can even fly in space. Well, you know, Jupiter and Saturn are putting on a great show. What if we go to Saturn? I can center it in the sky, or I can fly to it. I can see it as you would never see it from Earth, or I can move around to the dark side, that side opposite the sun. Great stuff. You can move forward and backwards in time, just like stellarium. So I just wanted to point out all the wonderful resources that are available to the lay public to help us learn about astronomy. And I'll stop there and see if maybe our wonderful team doing this presentation tonight, I'll give them a hand, can help us with any questions that the audience might have. You can feel free to go on the UACNJ website and try asking questions, or on our Facebook site. But I want to thank you for being such a good audience.
All right. Thank you, Lonny, for such a great talk. At this point, we would invite our live audience to ask any questions. Currently, there are none in chat. So while anyone who would like to ask any questions perhaps types them in there, we want to thank everyone for tuning in. We want to remind you, don't forget to hit that follow and subscribe buttons down below for some more live stream astronomy goodness. Please, like he said, check us out on our website, uacnj.org, and through social media such as Facebook, Instagram, and Twitter. We also thank you for putting up with our technical difficulties. Like I did mention earlier, we are experiencing a bit of weather here in New Jersey, which has made internet connections somewhat interesting, as I'm sure everyone has experienced before in their life. At this time, it looks like we do not have any questions. I do ask Lonny, please stay on the line after we do our outro. And like I said, Thank you, everyone, for tuning in, and hope you join us for the next time Astronomy Time runs around.